In a world where data is being generated at an alarming rate, the correct analysis of the data at the correct time can be very useful. Now, one of the most amazing framework to handle big data in real time and perform analysis is Apache Spark. And if we talk about the programming languages being used nowadays for different purposes, I'm sure Python will top this chart as it is being used almost everywhere. So guys, this is Kisle from Edureka, and today we'll be discussing about PySpark and explore the benefits of both the world that are the Python and Spark. Now let's have a quick look at the agenda. I'll start off by talking about Apache Spark, its features, and the various use cases of Spark in the industry. Then we'll understand why Python is best suited to work with Spark. And moving forward, we'll discuss the PySpark training provided by Edureka. We'll understand some of the important features like Spark RDD, Spark Context, and also Spark Streaming along with some examples and practicals. And finally, I'll finish off this video by showing you guys some demos on PySpark. So, talking about the features of Apache Spark, starting off with the most important feature, that is speed. It is almost 100 times faster than the traditional data processing tools and frameworks. It has powerful caching. The simple programming layer provides powerful caching and disk persistent capabilities. Now coming to deployment, Apache Spark can be deployed through Mesos or Hadoop via Yarn or via Spark's own cluster. The most important feature that helps Spark achieve the fast speed in real-time computation and low latency is the use of in-memory computation, the lazy evaluation of transformations, the didactic acyclic graphs, and much more. Now Spark is polyglot, which means it can be programmed in various languages like Python, Scala, Java, and R. And it is one of the reasons why Apache Spark has taken over machine learning and exploratory analysis. Now let's have a look at the various companies that use Apache Spark. Here we have Yahoo, Alibaba, Nokia, Netflix, NASA, Databricks, which is the official enterprise distributor of Apache Spark. We have TripAdvisor and we have eBay. So you can see Spark is being used in the industry a lot. Now let's have a look at the various industry use cases. First of all, starting with healthcare. As healthcare providers look for novel ways to enhance the quality of healthcare, Apache Spark is slowly becoming the heartbeat of many healthcare applications. Many healthcare providers are using Apache Spark to analyze patient records along with the past clinical data to identify which patients are likely to face health issues after being discharged from the clinic. This helps hospitals prevent hospital readmittance as they can deploy home healthcare services to the identified patient, saving on costs for both the hospitals and the patient. Apache Spark is used in genome sequencing to reduce the time needed to process genome data. It took several weeks to organize all the chemical compounds with genes, but now with Apache Spark on Hadoop, it just takes few hours. Now coming to finance, banks are using Apache Spark to access and analyze the social media profiles, call recordings, complaint logs, emails, the forum discussion to gain insights which can help them make right business decisions for credit risk assessment, targeted advertising, and customer segmentation. One of the financial institutions that has retail banking and brokerage operations is using Apache Spark to reduce its customer churn by 25%. The financial institution has divided the platforms between retail, banking, trading, and investment. However, the bank wants a 360-degree view of the customer regardless of whether it is a company or an individual. To get the consolidated view of the customer, the bank uses Apache Spark as the unifying layer. Now, Spark helps the bank automate analytics with the use of machine learning by accessing the data from each repository for the customers. Now, talking about media, Apache Spark is used in the gaming industry to identify patterns from the real-time in-game events and respond to them to harvest lucrative business opportunities like target advertising, auto-adjustment of gaming levels based on complexity, player retention, and many more. Now, Conviva is another company, averaging about 4 million videos per month. It uses Apache Spark to reduce customer churn by optimizing video streams and managing live video traffic, thus maintaining a consistently smooth, high-quality viewing experience. Now you all might have heard about Netflix. Netflix uses Apache Spark for real-time stream processing to provide online recommendation to its customer. Streaming devices at Netflix send events which capture all member activities and play a vital role in personalization. It processes 450 billion events per day which flow to the server-side application and are then directed to Apache Kafka. Now coming to the retail and e-commerce industry, one of the largest e-commerce platform, Alibaba, runs some of the largest Apache Spark jobs in the world in order to analyze hundreds of petabytes of data on its e-commerce platform. Some of the Spark jobs that perform feature extraction on image data run for several weeks. Millions of merchants and users interact with Alibaba e-commerce platform. Each of this interaction is represented as a complicated large graph and Apache Spark is used for fast processing of sophisticated machine learning on this data. Now, eBay also uses Apache Spark to provide targeted offers, enhance customer experience, and optimize overall performance. Apache Spark is leveraged at eBay through Hadoop Yarn. Yarn manages all the clusters resources to run the generic tasks, and eBay Spark users leverage the Hadoop cluster in the range of 2000 nodes, 20,000 cores, and 100 TB of RAM through Yarn. Now, finally, coming to the travel industry, TripAdvisor, a leading travel website that helps plan a perfect trip, is using Apache Spark to speed up its personalized customer recommendation. TripAdvisor uses Apache Spark to provide advice to millions of travelers by comparing hundreds of websites to find the best hotel prices for its customers. The time taken to read and process the reviews of the hotels in a readable format is done with the help of Apache Spark. Now, we all know Uber. Every day, this multinational online taxi dispatch company gathers terabytes of event data from its mobile users. By using Kafka, Spark Streaming, and HDFS to build a continuous ETL pipeline, Uber can convert unstructured event data into structured data as it is collected, and then use it for further and more complex analysis. So, as I was talking about Spark being a polyglot earlier, it basically means that programming in Spark can be done in various languages like Scala, Python, and R. Now, you may ask which one should I go or choose to begin with. So, Spark was developed in Scala, that you should know. It was the default language in which Spark was developed. It is very similar to Java, but the recent emergence of data analytics and machine learning has made it difficult for Scala to keep up. So instead, Spark came up with a Python API to use Python. So let's have a look at the reasons why one should go for Python to begin with. Firstly, it is easy to learn. For programmers, Python is comparatively easy to learn because of its syntax and standard libraries. Moreover, it is dynamically typed language, which means RDDs can hold objects of multiple types. Now we'll discuss more about RDDs coming up in this video. Now it's portable and it can be used with various operating systems like Windows, Solaris, Linux, we have the BOS, PlayStation, and the macOS. And lastly, Scala does not have sufficient data science tools and libraries like Python for machine learning and natural language processing. Spark MLlib, the machine learning library, has only fewer ML algorithms, but they are ideal for big data processing. In summary, we can say that Scala lacks good visualization and local data transformation tools along with highly used machine learning libraries. Now, Edureka, as we know, provides a detailed and comprehensive training on Apache Spark in Python, that is the PySpark Developer Certification Training. Now, this course is designed to provide knowledge and skills to become a successful Spark developer using Python. You will get in-depth knowledge of concepts such as Hadoop distributed file system, the Hadoop cluster, Flume, Sqoop, Apache Kafka. You'll learn about the APIs and the libraries which Spark offers such as Spark Streaming, MLlib, Spark SQL. And this PySpark developer course is an integral part of a big data developer's career path. This course is designed to provide knowledge and skills to become a successful Hadoop and Spark developer and would help to clear the Spark and Hadoop developer, which is the CCA 175 examination. This course has in total 12 modules with one bonus module, and it focuses on Cloudera's Hadoop and Spark Developer Certification Training. Now coming to Module 1, which is the Introduction to Big Data, Hadoop and Spark. In this module, you will understand big data, the limitation of existing solutions for big data problems, how Hadoop solves the big data problem, the Hadoop ecosystem, Hadoop architecture, HDFS, rack awareness, and replication. You will learn about the Hadoop cluster architecture, important configuration files in Hadoop cluster, and you will also get an introduction to Spark, why it is used, and understanding the difference between batch processing and real-time processing. Now coming to Module 2, which is Introduction to Python for Apache Spark. At the end of this module, you will be able to define Python, understand operands and expressions. You will be able to write your first Python program, understand command line parameters and flow control. You will understand how to take an input from the user and perform operations on it. And you'll also learn about numbers, strings, tuples, lists, dictionaries, and sets. Now coming to Module 3, which is basically the functions, oops, modules, error, and exceptions in Python. In this module, you will learn how to create generic Python scripts, how to address the errors and exceptions in the code, and finally how to extract and filter content using the regex. Now Module 4 is deep dive into Apache Spark framework. In this module, you will understand Apache Spark in depth, and you will also learn about the various Spark components. You will be creating and running various Spark applications, and at the end, you will learn how to perform data ingestion using Sqoop. Now coming to Module 5, which is playing with Spark RDDs. In this module, you will learn about Spark RDDs, which are the resilient distributed datasets, and other RDD-related manipulations for implementing business logistics, like the transformations, actions, and the functions performed on RDD. Moving on to Module 6, which is the data frames in Spark SQL. In this module, you will learn about Spark SQL, which is used to process structured data with SQL queries. You will learn about the data frames and the data sets in Spark SQL, along with different kinds of SQL operations performed on the data frames. You will also learn about the Spark and Hive integration. Now, Module 7, which is Machine Learning using Spark MLlib. In this module, you will learn about why machine learning is needed, different machine learning techniques and algorithms, and their implementation using the Spark MLlib. Now, 8th module is Deep Dive into Spark MLlib. In this module, you will be implementing various algorithms supported by a machine learning library, which is the MLlib, such as linear regression, decision tree, random forest, and many more. Now coming to Module 9, which is Understanding Apache Kafka and Apache Flume. In this module, you will understand Kafka and Kafka architecture. Afterwards, you will go through the details of Kafka cluster, and you will also learn how to configure different types of Kafka cluster. At last, you will see how messages are produced and consumed using Kafka APIs in Java. You will also get an introduction to Apache Flume, its basic architecture, and how it is integrated with Apache Kafka for event processing. Now, Module 10 is Apache Spark Streaming. In this module, you will work on Apache Spark Streaming, which is used to build scalable, fault-tolerant streaming application. You will learn about these streams and the various transformations performed on the streaming data. You will get to know about commonly used streaming operators such as sliding window operator and the stateful operators. Now, Module 11 is Apache Spark Streaming Data Sources. In this module, you will learn about the different streaming data sources such as Kafka and Flume. And at the end of this module, you will also be able to create a Spark streaming application. Now, Module 12 is the in-class project. Now, this project will comprise of all that we have learned till now. That is Hadoop, Spark, Kafka, Flume, and much more. And as a bonus, we have another module, which is the GraphX. In this module, you will be learning the key concepts of Spark GraphX programming concepts and operations along with the different graphics algorithms and their implementations. Now that we have seen the training structure offered by Edureka, let's understand what exactly PySpark is. Now, Apache Spark is an open source cluster computing framework for real-time processing developed by Apache Spark Foundation. And PySpark is nothing but the Python API for Apache Spark. Now let's have a look at the various components of the Spark ecosystem. The core engine of the entire Spark framework provides utilities and architecture for other components. Spark Streaming enables analytical and interactive apps for live streaming data. The MLlib, which is machine learning library of Spark, it is built on top of Spark to support the various machine learning algorithms. GraphX, computational engine, which is similar to Graph, combines data parallel and graph parallel concepts. Spark R is the package for R language to enable R user to leverage Spark power from the R shell. Now finally, we have the PySpark, the API developed to support Python as a programming language for Spark. Now, PySpark Shell links the Python API to the Spark core and initializes the Spark context. The Spark context is the heart of any Spark application. Spark context sets up internal services and establishes a connection to a Spark execution environment. The Spark context object in the driver program coordinates all the distributed processes and allows resource allocation. The cluster managers provides executors, which are JVM processes with logic. Spark context object sends the application to the executors, and then Spark context executes these tasks in each executors. Now, when you have installed Spark on your system, just by typing PySpark, you can enter the Spark shell, and it looks something like this. Just make sure that all the daemons of Spark are running in the background. Now that you have entered the Spark shell, it is important to know about RDDs. When it comes to iterative distributing computing, that is processing data over multiple jobs in computation, we need to reuse or share data among multiple jobs. In earlier frameworks like Hadoop, there were problems while dealing with multiple operations. We need to store the data in some intermediate stable distributed storage such as HDFS. The multiple I/O operations make the overall computation job slower, and the replications and serialization, which in turn makes the processing even more slower. RDDs try to solve all these problems by enabling fault-tolerant distributed in-memory computation. Now, RDD is nothing but resilient distributed datasets. Since RDDs are created over a set of transformations, it logs those transformations rather than actual data. It is a distributed memory abstraction which lets programmers perform in-memory computation on large clusters in a fault-tolerant manner. They are read-only collection of objects partitioned across a set of machines that can be rebuilt if a partition is lost. RDDs can be created for multiple data sources like Scala collection, the local file system, we have the Hadoop HDFS, Amazon S3, HBase table, and so many more. Now there are several operations performed on RDDs, which are the transformations, actions, and the functions. So let's have a look at the few transformations and actions. You can do the programming in Shell, or you can integrate your Jupyter notebook with Spark so that every time you start the Spark Shell, you are automatically redirected to the Jupyter notebook. Now personally, I find the Jupyter notebook a little bit easier to use because of the color combination and all that, but it comes down to your choice. So let me just start my VM. So before starting the Spark Shell, you need to check whether all the daemons of Spark are running. As you can see, worker is running, but still I'll stop and start it once again. Now this stop-all.sh will stop all the Spark daemons. Now to restart all the daemons, all you need to do is change the stop to start. So now if I check whether all the daemons are running or not, you can see the worker and the master is running. So let me start the Spark Shell. Just by typing PySpark, I'll enter into Spark Shell and I'll be redirected to the Jupyter notebook. So as you can see, it has automatically opened the Jupyter notebook for me. So all I'll do is select a new notebook of Python 2. Let's name it as RDD practice. So first we'll see how to take a text file as an input. So as you can see, I've created a RDD and we have used the sc.text file. So one important thing to note down here is that by default, the path you provide is for the HDFS path. So in order to take the file from your local file system, you need to mention the file : and 2/. Now to have a look at the output of the first 5 elements, all we need to do is enter rdd.take5. As you can see, I have the output, first 5 output. It is being mentioned as U 1, 2, 3, 4, 5. Now suppose if you want to convert all the words in the RDD to the lowercase and split those lines of the document using the space. For that, we'll create a function to do both the tasks. I'll show you how it's done. So as you can see in this function, I've taken the input in lines and I've converted it to dot lower, and dot split will split the lines. And I've created another RDD, which is the RDD1. So now if we take a look at the RDD1, you can see here all the words are in lower cases and everything is split. Now the output of this is so long, so if you want to flatten the output, we'll use the function, or rather I'd say we'll use the transformation flat map. So let me show you the flat map transformation. So here I'm going to create RDD2, which will take the initial RDD and convert it into a flat map function, and then we'll see the output of the first 5 elements. As you can see, we have the output as the Apache flat map output. Now suppose I want to remove the stop words in my file. We need to define the list of stop words in a variable called stop words. Now here I am selecting only a few words in the stop word list instead of all the words. Now applying filter to the RDD2 and looking at the first 10 output and comparing it with the initial one, we can see we have removed the, for, all these stop words which I have mentioned are not here. Now after getting the result into RDD3, we want to group the words in the RDD3 based on the letters that they start with. For example, I want to group each word of the RDD based on the first 3 characters. All I've got to do is use the group by transformation, or the group by action, I should say. As you can see, we have the ALO and the ALONG along. Now what if I want to work with the samples instead of the full data? Now the sample transformation helps us in taking samples instead of working on full data. The sample method will return a new RDD containing a statistical sample of the original RDD. We can pass the arguments inside as the sample operation. So as you can see in the RDD3.sample, I have given the parameters false, 0.4 and 42. Now false is basically the with replacement parameter. It is used to choose the sample with or without replacement. So I've given a false. Now fraction is 0.4, which means we want to choose the 40% of the data in the RDD. And the seed, which is 42, is used for the reproduce of the results. Now, if we want to join the two pair RDDs based on the key, we have the join transformation, which helps us do the right thing. First, we create the two sample key value pair RDDs, which are the sample 1 and sample 2. So now that we have created the sample 1 and sample 2, applying a join transformation on sample 1 and sample 2 will give us the desired output. So as you can see here, we are joining sample 1 to sample 2 and we are taking the first two output. I'll show you. As you can see, we have the output here UA, UT, we have the A, T and T, and we have the A, T and P. Now if you want to find out the sum of all the numbers in an RDD, the solution to demonstrate this, I will first create an RDD from the list of numbers from 1 to 10,000, and then we'll reuse the reduce action and pass a function through it, which is the lambda x and y such that the output is x plus y. And a reduce action is used for aggregating all the elements of RDD by applying pairwise user function. So now that we have seen some of the transformations and actions which we can perform on RDD, let's understand one of the use cases which we have here, which is the NBA use case. Now we are using the data from the basketball reference. So for that, I'll open a new notebook and I'll name it as NBA stats or NBA practice. Now here we are using the data from the basketball reference. We read in the seasonal total stats for every player since the 1979 to the 1980 season into the Spark data frame using the PySpark. So let me rename it as NBA practice. So as you can see here, we have a data frame and we are using the read dot option with header true and info schema true. You can see here I have taken the input data file from the local file system, which is the season totals.csv. So now we can also view the column names or our data frames. For that, we are going to print the data frame.columns. So as you can see, we have the underscore CO, which is the first column name. We have the player, position, age, team ID, the G, GS, MP, FG, just a 3-pointer, the first pointer, second pointer. We have the total points and we have the years. Now using our data frame, we can view the top 10 players sorted by number of points in an individual season. So notice we use the toPandas function to retrieve our result. The corresponding result looks cleaner for display than when we are using the take function. So as you can see, the output is much cleaner and in a proper format. Now next, using the data frame domain specific languages, the DSL, we can analyze the average number of 3 points attempt for each season, scaled to the industry standard, which is the 36 minutes. The per 36-minute metric provides an estimate of a given player's stats projected to 36 minutes, and an interval corresponding to an approximate full NBA game with adequate rest, while also allowing comparison across players that play different number of minutes. So as you can see here, we are using the group by, we are using the aggregation, we are using the select, we are using the order by. Now we compute this metric using the number of 3-point field goal attempts, which is the FG3A, and the minutes played, which is the MP. So as you can see here, we are taking the sum of the FG3A and dividing it with the column sum of the MP, which is the minutes played. Now that we have aggregated our data and computed the average attempts per 36 minutes for each season, we can query our result into the pandas data frame and plot it using the matplotlib. So as you can see, we are importing the matplotlib library here, and let us just compute and plot it. Now we can see a steady rise in the number of 3 points attempts since the shot's introduction in the 1979 to 1980s, along with a blip in the number of attempts during the period in the mid-90s when the NBA moved the line in a few feet. Now we can fit a linear regression model to this curve to model the number of shots attempted for the next 5 years. Of course, this assumes a linear nature of the rate of increasing attempts and is likely an assumption, but still, let's do the analysis. Firstly, we must transform our data using the vector assembler function into a single column where each row of the data frame contains a feature vector. This is the requirement for a linear regression API in MLlib. We first build the transformer using our single variable YR, which is the year, and transform our season total using the transformer function. Next, we'll build our linear regression model object using our transform data. Now next, we want to apply our train model object to our original training set along with 5 years of future data. Containing this time period, we build a new data frame transform it to include a feature vector, and then apply our model to make a prediction. So as you can see here, we are applying the model for the 1979 to 80 season through 2020 and 21 season. And we are building the test data frame and applying the linear regression model. So now when we want to plot our result, let's see what the result tells us. So as you can see, we have fitted a linear regression model to this one, and the prediction is till 2020. Now we have saved this image in our local file directory, which is the home Edureka downloads image section. I'll show you that. I'll go to the files. In the downloads, in the images, I have the regression. So you can clearly see here we have the linear regression line, and we have the future prediction here according to the model we created just now earlier. So this is it, guys. I hope this session was helpful, and I hope it helped you a lot in understanding the PySpark, all the features, the reason why to choose Python, training provided here at Edureka, and I hope you enjoyed this video. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!